Let's go right into our first question, which was sent to us by Mabutla V. Matsejo. This is basically an awesome question that is linked to analytical geometry to some extent. So let's go and see what this question says. It reads as follows. It says the diagram below shows a semicircle with the diameter OB along with the line 4x minus 3y is equal to 45. Right. Now, we've got a semicircle. We're normally used to working with full circles. But in this context, we have a semicircle. The first question says to us, we need to determine the equation of the semicircle. Now, let's take some time to analyze what do we understand about circles. You should know by now that if you've got a full circle, the defining equation of any circle is given by x minus a squared plus y minus b squared is equal to r squared. And you guys should know by now that for a and b, we're simply going to substitute the coordinates of the center. If you check our diagram, we don't know what the coordinates of the center are going to be. But we know for a fact that this circle passes through the origin, and it also passes through point B with coordinates 10 and 0. I think we can definitely conclude that in the middle, the coordinates are going to simply be 5, right? And the y coordinate will just simply be 0. Now that means I've got my coordinates of the center. I can simply say this is x minus 5 squared added with y minus 0 squared is equals to the radius. Now what is the radius? Well, this should be straightforward for all of you, because if you look closely in this diagram, you can see that we are expecting the radius to be the distance from the origin to the center. So that's basically going to be our r. And that is just 5 units from the origin. So that means that your radius will have a value of 5, which means I'm then going to have my r as 5 squared. Now, if I simplify this further, we just going to simply have x minus 5 squared plus y squared is equal to 25. This that you are looking at right now is the equation of a full circle. Now, they want you to write down the equation of half of this circle. So, it is at this point that I want to say this to you. We're looking at the equation of a circle. It's a full one, right? It says y squared here. So, I'm going to try and make y the subject of the formula. Something interesting is going to happen. You'll see it. Let's check this. So, what will happen is I have y squared equals 25. I'm subtracting x minus 5 squared on both sides of the equation. I end up with that x minus 5 squared. So I'm looking at y squared. Remember, if you want to make y the subject of the formula, you need to take the square root on both sides of the equation. That means my y will then be equal to the square root of 25 minus x minus 5 squared. Now what I'm looking at here is actually incorrect. Why? Because if you take a square root, you need to remember that it's always plus and minus. Well, what does that really mean in the context of what our graph looks like? In this case, it happens to be our circle. So the plus square root is responsible for the top half of the circle. So the plus square root part is responsible for the top half because those would be the y values that are positive. And then the minus part of my plus minus is simply responsible for the bottom half of the circle. And I'm interested in the bottom half because our drawing only has the bottom half. So which means my final solution to this problem will then be y is not plus and minus, but just minus the square root of 25 minus x minus 5 squared. You can break the bracket inside the radical sign if you want, but what I'm looking at here should be good enough as the solution to the first problem. So I hope you see what is going on here. The plus part is responsible for the top half, and the minus part is responsible for the bottom half of our circle. Right, so let's move on to the second question. We are being told here now that we need to prove that the line 4x minus 3y equals 45 is a tangent to the circle. You must never make assumptions. If you are not told that a particular line is a tangent, do not assume that that line is a tangent. Right, so now what am I looking at here? Well, I'm looking at a simple straight line that meets that particular curve or this semicircle at some random point that has no coordinates on it. So what I'm going to do is I'm going to introduce a point here, right? I'm going to introduce a point of contact. Let's call it point A, all right? Now, I'm going to attempt and see if I can find the coordinates of that point A, which is the point where this circle meets this particular straight line, right? Remember, if that's going to be a tangent to this straight line, something interesting needs to happen. What needs to happen? Well, think about it. If I draw, right, if I draw a line from the center to this, right, and I can prove that that line is perpendicular to that particular straight line that passes through point A, then I would have succeeded to prove that indeed that straight line we're looking at is a tangent in this particular case, because a radius will always be perpendicular to a tangent. So my attempt here is going to be the following. I'm going to try and find out if I can work out the coordinates of A. If I have the coordinates of A, then I'll try and figure out what is the gradient of the line from A to the center of the circle. There was nothing written for us here, so I'm going to introduce another variable. Let's call that variable maybe C for center. So what does that mean? That means I'm interested in proving that AC is perpendicular to the line that was given to us, right? If that's the case, then we can conclude that indeed it is a tangent to this particular circle. All right. Now, one person is asking, well, how are we going to even try and show that that line is perpendicular to the other one if we don't have the coordinates of A? Well, then the question is, can we find the coordinates of A? Let's go and try and figure out if we can do that. So I've got two equations. I've got the equation of that straight line, which I'm now going to write. It's basically 4x minus 3y is equal to 45. I want to solve that simultaneously, right? I want to solve this simultaneously against that, okay? Because that's where they meet each other. All right, so now for me to do that, I then have to do a couple of manipulations. I'll leave my minus 3y on the left-hand side, and then I'm going to take this as 45 minus 4x on the other side. Then I'm simply going to divide everything by negative. I want this to be 3y is equals to 4x minus 45. I just simply divided everything by negative. Once I'm here, I want to square everyone. So I square on the left and I also square on the right. Why? I'm trying to get this to be a square as well. That's going to be 9. Y squared is what we are looking at there, which is 16x squared minus 360x plus, I think it's 25. I might be wrong. Yes, 45 times 45 is basically 45 squared. It does give us 25. Okay, which I'm going to put here as 25. Now I've got y squared as 16x squared minus 360x plus 25, where everything is divided by 9. So I've got this equation, which I can call my equation 1. I want to compare this against this one here, which we found ages ago, the equation of half of this circle, right? Which I'm going to call equation 2. You can still take it from the last line, right? But you'll need to square on both sides if you do that. All right, so I'm going to take that one that says y squared. I've got that, which says y squared is equal to 25, right, minus, and then I've got x minus 5 squared. So this is going to be my equation 2. Well, they're both y squares, so I can just simply equate them. So that means I have now 16x squared less 360x added with 25. Everything over 9 is equal to 25 minus, let's work out the square. That's going to be x squared minus, it's going to be 10, right? 10x plus 25, okay? And then let's remove that, which then is going to simply leave us with 16x squared minus 360x added with 25 all over 9 is 25 minus x squared minus, and minus is going to be plus 10x minus 25. Now I need to remove that 9 in the denominator, just a matter of multiplying everyone by 9. That means all the terms on the right hand side of the equality sign are going to be multiplied by 9. So what you simply do is you've got 9 times 25. 9 times 25 gives you 225. So I'm sitting with 6x squared minus 360x plus 25 equals to, I'm just cross multiplying this 9 to that side, right? I end up with an answer of 225, and then 9 times x squared gives us minus 9x squared. 9 times 10 gives you 90x. There's another 225 again. When you're multiplying the 9 times the 25, it does give you minus 225 again, which you could have cancelled a long time ago because this and that are identical, they just simply cancel each other out. All right, now I'm grouping like terms. What do you notice? Well, this term here is friends with this term. When you add 9x squared on both sides, you're going to simply have 16 plus 9, which gives you 25. So I'm going to have 25x squared. I've got 90 and 360. On 360, when you subtract 90, right, remember that's negative. So this is going to be negative also when you take it to the left-hand side. So it's just as good as adding them. I'm going to get negative 450 from this, right? And then I'm still sitting with this number 25, which is equal to 0. Now, 25 can go into all these things. Divide all of them by 25, you get x squared. When you have 450, you're dividing it by 25, it gives you 18 of x's. And then on 25, when you divide it by 25, it gives you an answer of 81 is equal to 0. Now, I'm going to factorize this. What do you end up with? Well, guess what? We're just going to get a quadratic that has x times x. The factors of 81 are 9 and 9. They must both be negative so that they give me an answer of 18 in the middle. My x come out as one number, which is a 9. Now that I got a 9, I can then go back and try to figure out what my corresponding y value is going to simply be. So if I put y here, substitute 9 where you see x in either one of your two equations. I like this one of y squared is 25 minus. So I'm going to use that. Remember, y squared is 25 minus x minus 5 squared. When you use this to figure out what your y is going to be, you then have y is 25 minus my x is 9. So 9 minus 5 squared. 9 minus 5 squared is simply 4. 4 squared is 16. 25 minus 16 must give us a 9. So I'm sitting with y squared is 9. You take the square root on both sides, then your y comes out as plus minus 3. Based on the position of our point of contact, there where they meet each other, I'm ending up with an answer of minus 3 as the possible solution that makes sense. Remember, this gave me a 9, so I'm willing to take a minus 3 here instead of taking a 9, a plus 3. Why? Because, well, if you look at the positioning of that particular point A, it has to have a negative y coordinate. So my final answer here is basically going to be the point of contact between these two things, right, is one thing. Point of contact is at 9 and negative 3, right? Now, at this point, I don't even need to go and show you that the gradients are going to be perpendicular. I don't have to show you that the lines are perpendicular by calculating the gradient of the radius and showing that the gradient of the radius times that of the tangent gives us a negative 1. I could go on and do that. However, when I'm trying to solve this thing simultaneously, I'm only coming out with one point. That means these two graphs, they meet each other at one point. If I got two x values, it would mean that they intersected two places. Because I only got 1 point when x is 9, that means that straight line is basically a tangent to the circle. At the semicircle, it touches it only at 1 point when x is equals to 9. So that's the solution. And that will be your conclusion. Right. Let's move on to the second question. So that means since we're getting 1 point, 1 point of contact, that satisfies these two simultaneously. Therefore, we can conclude that the line is a tangent, right? Is a tangent. Only a tangent will meet a curve at 1 point.